Lightsaber VFX have always been my favorite VFX in Star Wars movies, especially when they like cut through doors like this. And since Disney doesn't really know how lightsabers work, we will show them how it's done by recreating this effect in Blender. For this tutorial, I created this little setup. I created this wall over here with a monkey inside of it, and these two objects are going to be the objects that we're going to cut with this lightsaber. And if you take a look, I created this little animation for this lightsaber so that it actually goes through our object and we don't have to like manually move it during the tutorial. You also see I decimated the monkey a little bit so that the geometry of it is really dirty, so that we can really see that this effect works on any mesh, no matter how messed up it is. I also added in this cube, and this cube is going to be the object that's going to carry the geometry nodes for us. So let's now start with creating the geometry nodes. So let's go into geometry nodes over here and click on new to create a new geometry nodes on this cube, and we can immediately delete the group input. I want to import my objects into this geometry nodes. And we're going to do this first by putting the monkey and the wall in one collection. So let's select them both and press M and do new collection and name this like collision or something like that. Click on the cube again that has the geometry nodes on it and drag in your collision object over here. If you don't want the geometry nodes to disappear when you click on a different object, you can click on this pin icon over here. And now if you click on another object, your geometry nodes will not disappear. I also want to add in our lightsaber, so let's click on that and let's go over here, and I have it like a parent as this object. So let's drag in our lightsaber into our geometry nodes as well. Also, when you use the collection in geometry nodes, you always have to do realize instances so that it actually uses the actual geometry of these objects, and you also have to do relative and separate children, and now you're good to go. The first thing that I want to do is distribute a lot of points that are in this collision collection. So let's do a distribute points on faces node and connect the realize instances with mesh, and let's do Alt Shift click on it so that we can see the points. We can make the density a lot higher, so let's make the density like 6000 or something like that so that we have a lot of points. And now we want to make it that only the points that are close to this lightsaber or that have been close to this lightsaber are disappearing, so that we're kind of creating like a trail of points. And we can do this with a simulation zone. So if we add in a simulation zone and we connect that all like this, then everything is gone. That's completely fine. What I want to do is I want to create a new attribute, and this attribute is going to simulate whether a point has been hit by the blade. So click on the simulation input, press N to make this sidebar open up, click on plus to create a new attribute and name this attribute is hit or something like that. This attribute should not be a geometry, of course, it should be a float. And then connect the isHit value of the ending isHit value. But how do we actually calculate whether a point is close to the lightsaber? Well, we can do this with a Shift A, add in a geometry proximity node. And as the target of the geometry proximity, we set the geometry of the lightsaber. And then you will see if you do Ctrl Shift click and click to preview the distance, and then also Ctrl Shift click on the distribute points on faces. And you see that doesn't really look good. That's because in the object info for the lightsaber, we have to set it on relative instead of original. Now you see the points around the lightsaber are becoming black or darker, and the points that are further away, the further away it is, the brighter a point gets. I actually want to reverse this so that the points are becoming brighter when they are closer to the lightsaber and darker when they are further away from the lightsaber. So if you add in a color ramp like this and you put it like that, if you switch the black part and the white part, then you see the closer you get this, the smaller your selection will be in the points. Let's set it kind of like this. This is going to be kind of our pencil, so with this we can draw a line where our lightsaber is going to be. So to do this, we can remove the viewer node for now. So what we want to do now is add in a math node and connect this like this so that every frame we can add to the isHit attribute this color ramp. And then if you do Ctrl Shift click click on this viewer, then you see it looks like this. You see that we're now really tracking where the lightsaber has been. So tracking which points have been hit. Now let's make it that everything that is white gets deleted and everything that is black stays there. So delete the viewer node and let's add in a delete geometry node and connect the isHit value to the selection. And then you see we're getting this. However, I actually don't want that it gets deleted like this. I kind of want that it keeps two trails of points, kind of like two trails of lava that follow the lightsaber. So to do this, we want to manipulate the isHit value a little bit. We want to add in a color ramp set that over here. We want to click plus to add in a new joint, and this new joint, we're going to make this perfectly white. And then the joint all the way to the right, we want to set this all the way to black. And then you see we're already kind of getting it. If I do Ctrl-Shift-click on this and Ctrl-Shift-click on the simulation output, you see we're getting a trail already. To get a little bit of a thicker trail, we can do Shift-A and we do a math node. And then if we set this from add to less than, then we're getting this. Now if you set the value of the less than lower to like 0.06, then you see we're getting this. And you can also, if it's still too thin, you can set in the first color ramp it a little bit higher, like this. And now if you connect this with the selection, you see we're getting a trail that goes like this. And it works really well. Look, if you press play, for example, and then we get this, then you really see it works like the lightsaber trail. And now we want to convert all of this into real lava looking. So to do this, actually quite easy. Let's do a point to volume node and connect it like this. Set the amount to size. And let's also add in a volume to mesh node. That we're getting this. In the points to volume node, set the voxel size on 0.01. And let's set the radius on 0.03. That we're getting kind of like a lava trail. And then the only thing for this one, what we have to do is making it shade smooth. So let's do set shade smooth, set it like this, and then it looks smooth. If I now click on the wall, for example, and I press H to hide it, then you will see, yeah, there is no connection point between these lava trails. There's not going to be any real magma or lava trail between this. But we want this. So we want to create like geometry that is following this trail as well. So kind of what we want to do is we want to cut a part of these geometries so that it has the shape that follows this. And to do this, we have to create more geometry for our cube. So if you go into edit mode for the cube and you do right click and you do subdivide, you can subdivide it like 40 times or something like that. Maybe even more. Let's set it on 60. Maybe even more. Let's set it on 80. Let's do 80. That's good. So that we have enough geometry to actually delete. If you have an object that is not so handy to subdivide, like this one, what you can do is press Shift D on this object to create a replicate, and on this replicate, just add in a remesh modifier and set the voxel size to 0.02, for example, so that you have a remeshed version of your object. Now you will have it that the original one, yeah, it doesn't really need to be in the collision collection anymore, because we will use the remeshed version to do the effect. So let's click on the original one and press M and move it back into our original collection. And now you could also choose for it to hide the remeshed one because we don't need to see it. We only want to have the effect from it. Okay, what we did before with the attribute isHit was we drew a line like we tracked which points are hitting. Right, so we drew a line on the points, but we also want to draw a line on the geometry that comes out of this realize instances node. So we also want to simulate that. Easiest way to do this is by connecting the realize instances over here with the simulation input. And then to make it easier for you to see, you can name this like real objects. And you can maybe name this like points, something like that. And then let's also add in a new attribute below the real objects attribute. So let's click on plus over here and let's make this a float. And let's name this isHit object, for example. And we basically want to do the same thing. So if you connect isHit object with isHit object and you Shift D this add node, and you also connect to this add node, this color ramp, now you're also drawing on our actual cube and monkey. And of course, we also have to connect real objects with real objects over there. Otherwise, it's not going to work. Let's now also add in a delete geometry, and let's connect real objects with geometry, and let's connect the isHit object with the selection. Let's now also click Alt-Shift-click on our object, but then you see nothing is really happening. That's because our collision object is still in the way. So let's press H to hide that for a moment, and then you see parts of that object are getting deleted. However, we want to have this reversed. We want to have it that this part is not getting deleted. So let's add in a math node, set that over there, and let's set this on less than, and let's set it on less than 0.01. just like that. And now you see we're getting a trail that goes like this. And this is especially cool when you join this with the lava that we've created earlier. So if you do a join geometry node and we connect it like this and we connect the lava with that, then you see we're getting a trail of lava and kind of magma. As you see over here, the trail that we just created is kind of clipping through our original objects. And we don't want this. So what we can do to fix this is kind of offsetting our trail a little bit outwards. Like pushing it a little bit outwards along the normals. And to do this very easily, you can do a set position node. And as the offset, we want to do the normal of each face. And then you see it explodes. That's because the normal is way too strong at the moment. We want to scale this down a little bit with a vector math node. Set this like this. Set this from add to scale and scale it smaller, like 0.01 for example. And then you see it hovers over it instead of clipping through it, which is good. Let's also do set shade smooth for our trail. This is already pretty cool. However, to make this effect look a little bit more alive, I think there should be like sparkles coming out of the lightsaber where it's hitting the object, right? So let's do that. And for that, we're going to ignore all of this for a moment. So I'm going to move it a little bit like this. And what I want is, let's do Ctrl-Shift-Click on our points so that we can preview those. I want to delete all the points that are not close to our lightsaber. And we can use, just as before, this geometry proximity node for that. So if we do a math node and set it from add to less than, we can set the distance as the value. And we want to say, okay, if the distance of each point is closer than, in this case, 0.5, it should be white. So if you do Ctrl-Shift-Click and Ctrl-Shift-Click, then you see this is the case. If you make this value lower, then we can mask out a lot of more points. Let's set it on a value like this. I actually want to reverse this, so we don't want to set this on less than, but on greater than, so that we have this, so that we can do a delete geometry node, and as the selection, we set the greater than node, like this. Now we can delete the viewer. The sparkling part, we're going to do that in 2 steps. First, we're going to create emitter objects, which are going to emit our sparkles. And then we're going to create the actual sparkles. So to create the emitter, we want to do Shift-A and add in a simulation zone. And in the simulation zone, we want to do a join geometry so that each frame we can join this geometry to our simulation. And then you see that looks like this. Now these points, these emitter points, I don't want them to be there forever because then they will push out points forever. I only want them to be there for like 2 frames or 4 frames or something like that. So to do this, to delete them after 4 frames, I want to track the age of each point. And we can do this by clicking on the simulation input and create a new attribute like this and name this age and make this an integer. Now to track the age of each point, we want to do a capture attribute node and set this from float to integer and connect age with the value because that's what we want to capture for each point. And then each frame we want to add 1 to this value. So do a math node, connect it like this, and we want to add 1 each frame and then connect it with the age. And now we're tracking the age of each point. And now we can say with a delete geometry and also with a compare node, if we set this on integer, we can say, okay, if the age is greater than, for example, 6 frames, delete it. And now if we press play, then this will happen. After 6 frames that a point is alive, it will be deleted. Let's set this even lower to like 2 or 3 or something like that. Now we have our emitter objects. Now let's create it that they actually emit points. So to do this, we want to add in another simulation zone. And we also want to do join geometry over here so that we can join each frame a new set of points. These points need to have velocity. So let's add in a velocity attribute in the simulation input by clicking on this plus icon again, and let's make it velocity. And let's make this a vector, since this has to be a direction. Now to make the points actually move, I want to do a set position node right after this. And then I connect the velocity with the offset and also with the end velocity. And now if you make this velocity, for example, 0.1, for example, then you will see the points will start rising up. Of course, they will not be rising up if you don't do Alt-Shift-Click on the simulation output over here. Then they will be rising up. We don't want them to be rising up, of course. I want these points to be pushed out according to the normal of the closest face that it's on. So to get the normal of each closest face, we can take over here our collection info and realize instances and Shift D this to here. And then to find the normal of the closest face, we can do a sample nearest node, set this from point to face and connect the realized instances with that. And then also do a sample index node and connect the index with the index and this geometry with this geometry. Set this from point to face because we want to have the data of the face. And then also set this from float to vector because the normal of each face is a vector. So let's now do a normal node so that we can track the normal of each closest face. And this, we want to add that to the velocity of each point. So we're going to make this velocity 0 again. And then if you do a vector math node and we set it over here and we connect this with this add node, then we can, if you press play, you will see it will start pushing it out. However, it goes way too fast, of course. So let's slow this down a little bit by adding in a vector math node, set it on scale and scale it down by 0.1. And now you will see it goes a lot slower. However, it's glitching a little bit. Let me unhide the cube. Because what is happening now is if a point travels from here, okay, now the closest face is this, but once it travels to here, this is going to be the closest face, so then it will travel to there. But that's not what I want. I want to make it that the beginning velocity stays the velocity, that it doesn't change velocity at all. So to do this, we can remove this add node and we can actually do a mix node, which we set on a vector. Vector B is going to be the normal direction. Vector A is going to be our current velocity. And then we set this into the offset and also into the velocity. Now we say with this vector, we want to say, okay, if the velocity is still the initial velocity, so still the 0, 0, 0, update it to the normal direction. If it is already the normal direction, then it should stay that direction. And we can do this with a compare node and set this from float to vector. And we want to say, okay, if this velocity is equal to 0, 0, 0, then it should be B. Otherwise, it should stay its original direction. And then we're getting this, which already looks a lot better. These points are now traveling for an infinite amount of time. So I want to delete them after a certain time. So also for these points, we want to track the age. So let's click on the simulation input and let's click on plus to add in a age attribute. And let's make this an integer again. And then also add in a capture attribute, just like before. Set this from float to integer. Connect the age with the value over here. Add in a math node so that we can add 1 each frame to this age, like this. And now we can say, okay, let's make a little bit more space over here and over there. And now we can say with a delete geometry node, if we connect that over here and also add in a compare node, we can say just as before, if we set this on integer, if the age is greater than, for example, 5, delete it. And now we're getting this. Now you see after 5 frames it gets deleted. However, it looks a little bit boring if all the points are going perfectly straight, right? So I want to add in some randomness to this. To add in some randomness, let's do a random value node and let's set this on vector. And then we want to add this to our normal direction by adding in a vector math like that. And let's connect this like that. And then if you also make the minimum value -1, this is what you're going to get. Way too strong, of course. Maybe I should have been a little bit smarter by actually switching the scaling node and the add node. So let's connect this one over here and let's connect this one over there. And then you will see it goes like this. You still see that some parts, it's not really that randomized because these and these and these are going in one line. If you want it to be even more randomized, you can set the seed value to be dependent on the scene time. So if you connect that like this, now you will see it's very much randomized. If you want to have a little bit less points, you can go into the previous simulation zone. And then in this greater than value, you can set this on 1, for example. And then you're getting a little bit less. Or you can also set in the greater than node over here the value lower. Now let's replace these points with icospheres by adding in an instance on points nodes. Add that in over here. And as the instance, we want to do an icosphere. And let's connect that like this. Let's make the subdivisions 2 and let's make the scaling of each icosphere a little bit lower with a random value node. Connect that with the scale and make the maximum value a little bit lower like this. And then you see we're getting sparkles. Maybe we can set it even lower to like 0.1 or something like that. This is going to be especially cool if we now combine the 3 components together. So we already have a joint geometry over here, so we can just connect the instance on points with that joint geometry. And then let's take a look. We're getting this. Pretty cool. By the way, if you want to have this Blender file that I'm working on, you can find it on my website, ntranimation.com. That's where you can also find the project files of all the previous videos that I've created. Let's now do the materials. So let's go into material preview mode and let's split our screen in half over here so that we can switch to the shader editor. We're going to create two materials, one material for the lava and one material for the middle trill. And the material for the sparkles will be the same materials as the material for the trill. For the lava, I used this material from textures.com, link in the description so that you can download that as well. So I'm quickly going to import those textures with the Node Wrangler add-on. So click on the Principled BSDF, do Ctrl-Shift-T, and then search for your images. This one, this one, this one, this one, this one, and do Principled Textures Setup. Then you see it doesn't really work. Well, it's the same story as always. We're working with geometry nodes, so we have to set that material in geometry nodes. Let's rename this material to like burn or something like that, or lava or something like that. And let's do in geometry nodes a set material, and let's make this the lava material. And you see, yeah, it's pitch black. That's not really what we want. That's because these images are now mapped according to the UV map of this object. However, this object doesn't have a UV map. So we're going to do this in a different way. We're going to set this to object like this. And then you see, we're already getting it. However, it's now kind of like this, that the texture is projected from top to bottom, just vertical and not from the side. And I want to make it that it's kind of like a box that's like projecting it like this. So if you select all your images like this, and then you hold down Alt and you change this from flat to box, and you hold down Alt as well, and you make the blend a little bit more, then you see it changed it for every image at once, and then you see it looks pretty good. Now to make it a little bit look more like lava, I'm going to use this ambient occlusion texture as the emission map. So if you do a color ramp, and you set that over here, and you set this color ramp, you switch the black part and the white part, and you set this from linear to B-spline so that we have a little bit of a softer edge. Now if you make this stronger with a math node, set to multiply, and you set this on multiply by 100, for example, then you see we have our lava emission mask. This lava emission mask, we want to connect this with the emission strength. And then if you do Ctrl-Shift-Click on the Principled BSDF, nothing happens yet because our emission color is not the right color. If you want to have the right color for lava, just do a black body node and connect that with the emission, and then you see we're getting this. Now let's do the material for the middle trill. So let's go into the material properties over here, click on plus to create a new material, and let's do middle part, something like that. And then for this, we're literally going to delete the Principled BSDF and add in an emission texture. And by the way, let's also make it that we can see our emission on our object by doing a set material over here. And let's make this the middle part so that we can see it over there. As the strength of the emission, I want to do a noise texture, set the factor into the strength so that we're getting this. Press Ctrl-T on the noise texture to add in a texture coordinate and a mapping node. Set this on object so that it's mapped a little bit better. And then we want to change the scaling of this noise texture to 10, the detail all the way to 15, and the distortion to 1.3. Let's now create a little bit more contrast with a color ramp like this. And let's set this on B-spline as well so that we have softer edges. That looks good. And let's multiply this strength value with a math node set to multiply with a value of 1000. The emission color, I want to set that on black body as well. So let's connect that like this. To add in a little bit more detail, I think it's cool if we add in like an ambient occlusion node and also a color ramp. We connect that. And to see the results of this ambient occlusion, we actually want to go into render view mode. And then also from Eevee into cycles, turn on your GPU if you have one. If we do Ctrl-Shift-Click on this and we drag the black part to here, then you see we start having more contrast over here, which is good, which is exactly what I want. Because now we can multiply our noise texture with this ambient occlusion. And then you see we're getting cool detail like this. Now the very final thing that we have to do is taking this set material node from the middle part and shift D it to the sparkles so that they also glow. So that's how you create one of the coolest Star Wars VFX in Blender. If you like this video, please give it a thumbs up, comment down below if you have any questions, and if you don't want to miss out on any future videos and you want to support the channel, please consider subscribing. And if you ever need personal help in Blender, hit me up on Fiverr because there I provide personal Blender lessons. And with that being said, I see you in the next one.